Hold it with this hand so that you can write with the other.
Okay.
So, have you discussed the payment?
Which payment? Abio. The payment. Yes, you can come out. No.
Yeah, you disturb, yeah.
You guys are stressed already, are you?
We are straight. I'm very happy. I'm very happy. How do you see that?
Happy to be in the class.
Sir, if us is very
So you are not stressed yet. This is just the beginning. I'm stressed. Because we are still not done anything this course.
Jacobi and Ashilana. You've not done anything.
So I need someone's phone. Who has the... I prefer 100. Why you call it something? You have the classroom now, you have data. You are on the classroom, the Google classroom, you have data.
Nibu.
I'm aware with
I usually dictate note for you from there. Yeah. Do you have the phone? No.
Oh, Google Classroom.
Open the Google Classroom. I didn't get it.
The midnight.
How are you? They are coming. Yeah, practical.
Alright, good morning. Good morning. So I sent the questions for today. We are dealing with differential equations. And here, it means that you will be given derivatives. For instance, you know that you are given a function f of x equal to x squared, and you differentiate f of x. You're going to get f prime of x and c f prime of x equal to 2x. I will get that. So, in differentiation, you are getting back this derivative, and in integration, you have done integration before, you are getting back the function from its derivative. So when we talk about differential equations, it simply means equations carrying derivatives. Okay, so that means, for instance, if I denoted this as y, I would say that y is equal to this, and this means that y prime is equal to this. Okay, in another format, I can say that this is the y, the x is equal to 2x. And I can rearrange this and say that I have the y is equal to 2x dx. Does that make sense? Okay, this is an example of a differential equation. This is an example of a differential equation. An equation where you have derivatives and you want to get back the original function. So in this case, if this is a differential equation, to solve this differential equation means that we want to get back our function f of x. Okay, this derivative will simplify to this. Is that very clear? Is that making sense? Alright, you can also see that if you differentiate this function again, you can get y prime prime, which is the square y x squared. Are we together? The square y x squared is going to be equal to 2. Does that make sense?
Yes.
Alright. And you will notice that if you put this together, for instance, just merely observing these two, I can say that x multiplied by the square y, the x squared, okay, that's going to give me 2x, right? Then minus, what's the be given a problem like this, and then you are asked to find the y, the x, or you are asked to find y at the end of the day. Does that make sense to you? So this is an example of a differential equation, this is an example of a differential equation, and so on and so forth. So here, we will deal specifically with ordinary differential equations. Ordinary differential equations means that we have ordinary derivatives there, just like what we have here. What is the alternative to ordinary derivatives? You can have partial derivatives, say del y, del s. Are we together? Okay, so if you have something like this, this is called a partial differential equation. Is that clear? But solving or solution of partial differential equations is beyond the scope of this course. So we'll just deal with ordinary differential equations. So that means that in this course, you will have to deal with the y, the x, the square y, the x square, and so on and so forth. Then you will be required to find y at the end of the day. So solving the differential equation means that you want to get that function y equals to f of x that satisfies the differential equation. That's there. And so this can also be written in terms of, please pay attention now. This can also be written in terms of y. That means you can have y inside this equation. For instance, if I multiply this through by x, I'm going to get something like x squared, the square y, the x squared, minus x, the y, the x is equal to 0, right? I can decide to conjugate this equation and say that since x squared is equal to y, I can say this equation is y, the square y, the x squared, minus x, the y, the x is equal to 0. So you can have y even in that equation. Is that clear? And so it gets complicated. This is still another differential equation. And you will be asked to solve differential equation. It's still the same thing. You want to get y as a function of x. Is that clear? And of course, just like with integration, you will usually have constants of integration at the end of your results. Altogether, you usually have constant of integration. For instance, you can have this function y is equal to x squared plus constant. If you have any constants here, so by the time you differentiate this, y prime is still going to give you 2x, abi? And y prime is still going to give you 2. Altogether, that means that if I want to solve this backwards, I want to actually solve this differential equation, I'm going to have some constants at the end of the day. Does it make sense? You understand this idea? Right, so that's about that. So let's deal with some of these and see how it works. So look at the first question there. Is it a question? Not a question. Just listen out the different kinds of differential equations you can have. Okay? In this question, you can have what we call the ordinary differential equations, which we'll talk about. You can have partial differential equations, which has to do with partial derivative. And you can have what we call delayed differential equations, stochastic differential equations, fractional differential equations. Don't bother about all of this, you don't need them. So just know the different types we have. Right? Number 2, you have to determine if each of the following equations is linear or non-linear. So how do you determine if an equation, the differential equation, is linear or non-linear? So look at the options here. Look at the first one. The square y, the x squared, plus the y, the x, minus 1 equals 0. You have the y, the x, raised to power 3 equal to x plus 3. You have the y, the x is equal to x. And then you have the y, x is equal to 3 raised to power x plus 3 raised to power y. You have x squared, the square y, the x squared plus x is equal to xy minus y. Alright, so look at this now. How do you determine if a differential equation is linear? Please pay attention, pay attention. Look at this now. I'm going to give you a substitute statement later, but pay attention to this. It's linear. Now, when you're given a differential equation, you should first be able to identify which is the dependent variable and which is the independent variable. Altogether, in the case of ordinary differential equations, you will have only one independent variable. When you have partial differential equation, you are likely going to have more than one independent variable. Is that clear? Okay, so in this case, what is the dependent variable? So the dependent variable is the one that depends on the other, okay? And when you are actually taking a derivative, for instance, if I have something like x is equal to function of y, in this case it is x that depends on y. So if I'm taking a derivative of this, I'm going to have the x, the y. So the one at the numerator, are we together? It's the one that is the dependent variable. The one at the denominator is the independent variable. Is that clear? Is that clear?
No.
Okay?
No.
So this is going to give you f prime of y. Okay? I mean that whenever you are given this equation, you can identify that for you to get the square y, the x squared, what was differentiated? Y was differentiated with respect to what? X. The one that was differentiated is the dependent variable because it means the value of y depends on the value of x. That means y is a function of x. Is that making sense?
Yes.
Alright, and the other one is the independent variable. Does it make sense?
Yes.
Alright, so in this case, y is our dependent variable, x is the independent variable. So the same thing with every other expression you are given here. Is that clear?
Yes.
So when we say that a differential equation is linear, we are, please pay attention now, we are saying that the dependent variable and all its derivatives have only powers of 1. Are we together? They have only powers of 1. That means that you cannot have anything like y squared. You cannot have anything like the y, the x raised to power whatever that is not 1. Are we together? You understand what I'm saying here? Yes. Okay? Just like if you say that you have a linear equation, linear means the highest power is 1. Is that clear? You cannot have any power above 1. So your power of y will always be 1 or nothing. Power of the y, the x will be 1 or nothing. Power of the square y, the x square will be 1 or nothing. Power of the cube y, the x cube, if it's present, will be 1 or nothing. Do you understand that? Do you understand that? So that's what makes your differential equation linear. Alright, so if you look at this now, so another thing aside that condition is that you cannot have a product of the dependent variable and any of its derivatives. That means that I cannot have anything like y squared. I also cannot have anything like y, the x. So this is a product of the dependent variable and one of its derivatives. Is that clear? So if I have something like this, it makes the equation non-linear. Alright, so looking at the options now, so let's follow this. Looking at the options, look at the first one. I have the square y, the x squared. That is linear, right? Because its power is 1. Here, the y, the x, its power is 1. Abi? Aha. So I said it's either 1 or 0. Y is not present here. So this is what? Linear equation. Does it make sense? Alright, look at the second one. Is it linear? No. Because of the power here being 3. Is it clear? Okay, the next one. Y, the x equal to x. Is it linear? No. Because you have product of y and its derivative. Then the next one. Is it linear? Yes. Is it linear? Yes. Okay. It is not linear. I'll tell you why. Okay, the next one. Is it linear? Yeah, carefully. Is it linear? The next one. Yes. You have the square y, the x square, Abby, and then you have y alone. Are we together? Do you understand that?
No.
Okay.
No, sir. Please come again.
For the last one.
The last one.
Yes.
You have y and its derivatives. They don't have any power, Abby, outside 1. Is that clear? Y and all its derivatives do not have any power outside 1. Is that correct? Yes. There is nothing like this squaring, Abi. You are not squaring this. And you are not multiplying it by y, so it is linear. If you open this bracket, you are not multiplying it by y at all. Abi? That is linear. This is y, I'm multiplying it by x, that is not y, Abi. So it is still linear. Does that make sense? Does it make sense? Alright. Now because of this exponent, this one is also non-linear. Is that clear? Because of this exponent. So you can only have y alone, out together, or you have it as a coefficient to some other expression altogether not involving y. So you cannot have this expression. This already makes it non-linear. The same way you cannot have anything like sine y or cos y or cos of the y dx or anything like that. That will make it non-linear. Does it make sense? Does it make sense? Alright, so those are the linear equations. This is linear, this is not linear, this is not linear, this is not linear, and this is linear. Is that clear? Is that clear? Okay, so that is bad about that. Then the question then asks that if it is linear, determine if it is homogeneous or non-homogeneous. If it is linear, determine if it is homogeneous or non-homogeneous. So pay attention to this now. So please listen now. Homogeneous means that, listen please, homogeneous means that it has no term that does not carry y or the y dx. That means there will be no term in that linear equation that does not have y altogether or one of its derivatives. Is that clear? Okay, let me repeat myself. If being homogeneous means that you will have no term that does not carry either y or one of its derivatives. Is that clear? Is that clear? Okay, so this is not homogeneous. Why? Because of this minus 1. If this minus 1 was not there, that would be homogeneous. Because by that, all the expressions, all the terms will have either y or its derivatives. Is that clear? Okay, so if you consider the other one too, for this, is it homogeneous? Yes. Is it homogeneous? No, you open the bracket, this will be x raised to power 3. Abi? This will be x raised to power 3. By the time you open this bracket, and x raised to power 3 will be standing alone. Is that making sense? When you open the bracket here now, this will be x squared, square y, x squared, then plus x to power 3 equal to xy minus y. Does it make sense? Do you understand that? You now have x cubed, which is not carrying any x. Is that the any y or derivative of y? Is it clear? Is this clear? Yes. Minus y. So let me give you a formal definition.
There are so many independent.
What do you mean?
What do you mean?
How many G? Is it 3G? Why is it not slow?
I don't know.
MTN network has been bad sharp. It's not about your phone. You know that phone.
No, we've talked about
Maybe
we have
you may not understand the way they
term
say linear.
homogeneous twice now. We used homogeneous yesterday to mean a different thing. Can you remember that? We used homogeneous yesterday to mean a different thing. So please don't mix them up. So this concept actually applies to linear differential equations. Is that clear? It's when the differential equation is linear that will now consider whether it is homogeneous or not. Okay? So you can consider homogeneity in that respect.
Okay. I didn't mean to.
Sorry.
Okay. So this one now is non-linear because
Alright, right is right. The differential equation,
if
the
it is
differential
minus one, we
equation
need
is said to
to.
be linear.
It's just the power they are talking
The
about.
differential equation is said to be linear if the dependent variable and its derivatives appear linearly. That is only as first powers. Comma, they are not multiplied together. That is only as first powers, comma, they are not multiplied together, comma, and no other functions of the dependent variables appear. No other functions of the dependent variable appear. And no other function of the dependent variable appear. No other function of the dependent variable appear. Do you get it now? That's just putting everything I was explained down together. Appear only linearly. Linearly means that you have only power of one. Altogether, or nothing at all. And so if you want to write the general form of it, look at this expression. So this is a very common OBJ question. Please, so just know the differences. You can have something like this: a n of x, n y, x plus a of n minus 1 of x, n minus 1 of y, x n minus 1 plus so on and so forth, plus finally a1 of x, y x plus a naught of x, y x, sorry, a naught of x, this one will just carry y, then plus b of x. That's what we mean by linear differential. Okay, do you understand this idea? Do you understand this? So this is just a general expression for a linear differential equation. You always have either, please pay attention now, either the particular derivative is alone or it has a function that depends only on x. Is that clear? You cannot have it depending on y or be multiplied with y altogether or any other derivative. So it goes on like that, including for y. You cannot have any other thing that carries y multiplying y. Is that making sense? And then at the end of the day, you may have outside some other function that depends only on x. Is that clear? Is it clear? Alright. And that means for homogeneous linear differential equation, you now see that when our b of x is equal to 0, the equation is now said to be what? The equation is now said to be homogeneous. The equation is said to be homogeneous. Do you understand the generalization now? Okay. Because when b of x equals to 0, that means all the terms either have y or derivatives of y. Is that making sense? All the terms either have y or derivatives of y. So that's another way to put it. So that is when our v of x is 0. So you can see that this will be our v of x. So if I were to arrange this equation, look at it now. We identify this as a linear differential equation. If we were to arrange it in this form, it will be like this. We're going to have x squared, b square y, x squared, plus x cubed, Abby. So let me put the ones carrying x together first. So let's bring that, what we have there, to the other side. So that's going to be minus xy plus y. Okay. So I can carry the one that carries only x also to the other side. That will be minus x cubed. So at the end of the day, you can see that we have x squared, b square y, x squared, minus y, or let's say plus y. So y is what? What are you going to have? 1 minus x, y, equal to minus x. You get it now? So you can see why it is not homogeneous. Because in this case, this will be our v of x, and it is not 0. Does it make sense? Yes, if it were homogeneous, then this will not be 0. And every other thing will carry either y or the derivatives of y. Does it make sense? Yes. Alright, let's move on now to the next problem. Number 3. Okay. Okay, I'm coming.
Where's my Then that means look for them. See, this one is supposed to be homogeneous now. We're supposed to be 0.
We only consider it for linear differential equations. So once they are not linear, there's no discussion of whether it is homogeneous or not.
But the first one,
Yes.
where it can be non-homogeneous, it's also linear.
When it is non-linear, we are not discussing
need for
homogeneity.
What the one?
Okay, there's one I skipped. Roman figure 4, Abby. You can see Roman figure 4. What would you say about Roman figure 4?
Yes, sir.
It is linear and homogeneous, right? Roman figure 4 is linear and homogeneous. Do you understand that? Alright, so let's move on now. Roman figure 4 in the question.
I agree.
Can we move on now? Yeah, now there's no time now, no time. Number 3. Classify the following equations. Are they ODE or PD? That is, for each of them, you answer whether it's an ordinary differential equation or a partial differential equation. Then, what is the order of the differential equation? Is it linear or non-linear? If it is linear, is it homogeneous or non-homogeneous? Can you see that?
Yes, sir.
Aha. Look at something now. When we talk about the order of a differential equation, please pay attention now. We're just simply saying what is the highest order derivative altogether that you have in the differential equation. Do you understand what I just said now? Highest order derivative. That means that, is it, listen now, what is the highest derivative you have in the expression? Is it first derivative? Does it carry only the y, the x? Does it have second derivative, like the square y, the x square? Does it have fourth derivative altogether? Okay, like the y to power 4, the x to power 4. Do you understand me? Okay, so look at something now. That's the highest power of the derivative. No, not the highest power. The highest ordered derivative is what determines the order of the differential equation. Do you understand what I just said now? Did you get what I just said? Okay, the highest ordered derivative that is in the differential equation. That's what we mean by order of the differential equation. Okay, so there is also another expression. Listen. There is what we call the order of the differential equation, and there is what we call the degree of the differential equation. Order has to do with the derivative, okay, that is present, whereas degree has to do with power of the derivatives. Is that clear? Just like if you are talking about degree of a polynomial. Degree of a polynomial is the highest power, Abi, of the terms you have in the polynomial. Is it making sense? Alright, the degree of the differential equation will now be the highest power of the derivatives present in the differential equation. Is that making sense to you? The highest power of the derivative. So in this case, order simply means what is the highest derivative you have there. Is it making sense? So let's think about these options again. So what is going to be the order of this differential equation? Order 2, because this is the highest derivative you have there. Is that clear? What of this? What's the order of this differential equation? 1. What of this? 1. What of this? 1. What of this? 2. Okay? That means for this, what will be the degree? 1. Degree is 1. And the degree here is what? 3. The degree here is what? 1.
No. 2 actually. 2.
Okay, what's the degree of this one? 1. What's the degree of this?
1.
1, I mean. Okay. So,
Why is it 2, bro?
I just explained something to you. Let me give you a formal definition. Then we'll look at those. Right now, right. The degree of a differential equation. The degree of a differential equation of a differential equation is defined as the power